Good morning, all. So let us see again a few more problems on calculating the area bounded by polar curves in today's class. So the first problem is to find the area of the region enclosed by the rose curve r equal to 6 cos 3 theta. So here we have r equal to 6 cos 3 theta. Upper n value is equal to 3. Now when n is odd, you will be having n equally spaced petals and it will be traced exactly once in the interval 0 to pi. So that's what we have seen from the general rose curves. Okay. So when n is odd, the curve has 3 petals and the curve is traced exactly once in the interval 0 to pi. So area is given by integrating 1 by r square d theta over the interval 0 to pi. So let us substitute r square. So you will get 36 cos square 3 theta. So that will be equal to integral 0 to pi 1 by 2 into 36 cos square 3 theta d theta varum. Now cos square 3 theta can be written as 1 plus cos 6 theta by 2. So that will give 18 by 2, which is 9. 9 times integral 0 to pi 1 plus cos 6 theta d theta varum. Now upon integrating you will get 9 times theta plus sine 6 theta by 6 from 0 to pi. Now upon applying the limits, the first term limit will be pi minus 0 varum. Second term sine 6 pi minus sine 0. So both the limits are 0. So for the first term you get pi. So the value is going to be equal to 9 pi. Now the second problem is to find the area of the shaded region. So we are given a shaded region r equal to root of cos 2 theta and r equal to 2 cos theta. So the shaded region is a part of these two curves. Okay, അപ്പോൾ ആദ്യം ഏത് curve ഏതാണെന്ന് ഐഡൻറ്റിഫൈ ചെയ്യുക and find out in this region angle എവിടം തൊട്ട് എവിടം വരെയാണ് vary ചെയ്യുന്നത് നോക്കുക. Okay. So when you take r equal to 2 cos theta, that is a circle which is centered at the x-axis. So this is a circle centered at x-axis of radius 1, because it is in the form 2a cos theta, a value is 1, upper radius 1 ആയിരിക്കും. Okay. Now when r is equal to 2 cos theta, അപ്പോൾ theta equal to 0 ആകുമ്പോൾ value will become 2, and when theta is equal to pi by 2, the value will be 0. So this will be the curve r equal to 2 cos theta. For this curve, that will be taking the value. For theta equal to 0 വരുമ്പോൾ cos 0 1 ആവും. So r ന്റെ value 1 ആയിരിക്കും. ഇനി cos 2 theta will become 0 when theta is equal to pi by 4. അപ്പോൾ നമ്മൾ theta equal to pi by 4 എടുക്കുമ്പോൾ cos 2 pi by 4 gives cos pi by 2 വരും. Cos pi by 2 is 0. So this will be 0. അതായത് 0 to pi by 4 വരെ ആണ് r equal to root cos 2 theta ഈ റീജിയനിൽ ട്രേസ് ആയിരിക്കുന്നത്. ഓക്കെ, അപ്പോൾ ഈ കേവ് ഇവിടെ പൈ ബൈ 2 ആംഗിൾ ആകുമ്പോൾ എത്തും, ആൻഡ് രണ്ടാമത്തെ കേവ് ഇവിടെ എത്തുന്നത് ഈ പൈ ബൈ 4 എന്ന് പറയുന്ന ആംഗിളിനാണ്. ഓക്കെ, നൗ So therefore, we will get this. So for r equal to, so this is going to be the curve, r equal to root of cos 2 theta. So for r equal to 2 cos theta, so you can see that theta will vary from 0 to pi by 2. അതുപോലെ r equal to root cos 2 theta എടുക്കുമ്പോൾ theta will vary from 0 to pi by 4. Okay. Now, നമുക്ക് ഷെയ്ഡഡ് പോർഷൻ്റെ ഏരിയ ആണ് കണ്ടുപിടിക്കേണ്ടത്. Okay. So, when theta varies from 0 to pi by 2, അപ്പോൾ നമുക്ക് കിട്ടുന്നത് ഈ സെമി സർക്കിളാണ്. ഓക്കെ, സെമി സർക്കിളിൻ്റെ താഴെയുള്ള ഏരിയ ആണ് കിട്ടുന്നത്. ഇനി അതിൻ്റെ അകത്തുനിന്ന് we need to subtract this area under r equal to root of cos 2 theta. So that will give us the required area. So when you subtract this smaller area from the area of this semicircle, we will get the required shaded region. So therefore the area of shaded region will be integral 0 to pi by 2 1 by 2 ഈ ആറിൻ്റെ വാല്യൂ വരും. അപ്പോൾ 2 cos theta whole square d theta minus 1 by 2 integral 0 to pi by 4 root of cos 2 theta whole square d theta. So upon squaring we will get 1 by 2 into 2 square വെളി വരും. So cos square theta will be 1 plus cos 2 theta by 2 d theta, then minus 1 by 2 into integral 0 to pi by 4 cos 2 theta. So upon integrating, we will get, so this 2, both the 2's will cancel off here. So we will get theta plus sin 2 theta by 2 from 0 to pi by 2 minus 1 by 2 sin 2 theta by 2 from 0 to pi by 4. So upon applying the limits, we will get pi by 2 for the first term, and in the second term minus 1 by 4 into 1 vary. So the value of or the area of the shaded region is going to be equal to pi by 2 minus 1 by 4. So this is the required area. Let us look at one more similar problem. So the next one is to find the area of the shaded region. So we are given the shaded region r equal to 1 plus cos theta and r equal to cos theta. So r equal to cos theta എന്ന് പറയുന്നത്, that is again a circle which is centered on the x-axis. അപ്പം ഈ curve ആണ് r equal to cos theta, and r equal to 1 plus cos theta, that will be cardioid. So this is the cardioid. അപ്പം this will be 1 plus cos theta. Now we need to look for what is the variation of theta in this given graph. Okay. So when you take r equal to cos theta, theta equal to 0 വരുമ്പോൾ, so for r equal to cos theta, so when theta is 0, r value will be equal to 1, that is this point, and theta equal to pi by 2 എത്തുമ്പോഴത്തേക്കും r value 0. So then for r equal to cos theta, so in the given region theta varies from 0 to pi by 2. ഇനി അതുപോലെ നമ്മൾ r equal to 1 plus cos theta എടുക്കുമ്പോൾ, so let us look at the theta and r values. When theta is 0, the value is going to be equal to 2. Okay. അപ്പോൾ ഇതായിരിക്കും വാല്യൂ വരുന്നത്, 2 വരും. That is the maximum value. Cos in the maximum value 1 ആണ്. So this is the maximum value taken by r. So this will be 2. And when theta is equal to pi by 2, cos pi by 2 is 0. So the value is 1. അപ്പോൾ ഇവിടെ എത്തുമ്പോൾ 1 ആവും. So at pi by 2 the value is 1. And when you take pi cos theta will be -1, so r value is going to be 0. അപ്പോൾ കർവ് ഇവിടെ നിന്ന് ഇങ്ങോട്ടേക്ക് ട്രേസ് ആകുമ്പോൾ പൈ വരെയുള്ള ആംഗിൾ കവർ ചെയ്യും. സോ r equal to 1 plus cos theta, for r equal to 1 plus cos theta. So theta is varying from 0 to pi. So for the circle, theta is varying from 0 to pi by 2. Now the required area will be the area of the area under the cardioid. അപ്പോൾ കാർഡിയോയിഡിനെ 0 to pi വരെ ഇൻ്റഗ്രേറ്റ് ചെയ്യുക. So from that subtract the area under the circle. So for that we need to integrate from 0 to pi by 2 this curve r equal to cos theta. So the required area will be 1 by 2 integral 0 to pi 1 plus cos theta whole square d theta minus 1 by 2 integral 0 to pi by 2 cos square d theta. So upon integrating we'll get, so simplify there square expand area. So upon simplifying, then cos square theta can be replaced by 1 plus cos 2 theta by 2. So upon integrating, so we'll get 1 by 2 into 3 pi by 4 minus pi by 8. So that is 3 pi minus pi by 8, which is equal to pi by 4. So that is the required area. Now the next problem is to find the area of the region inside the circle r equal to 3 sin theta and outside the cardioid r equal to 1 plus sin theta. And now let us first draw the diagram of the circle and diagram of the cardioid. So circle this will be the circle. So r equal to 3 by 2 sin theta. So when you have r equal to 3 sin theta, not 3 by 2, r equal to 3 sin theta. So we will get 2 into 3 by 2 sin theta. So the radius is going to be equal to 3 by 2. So that is going to be the radius, and the total diameter of the circle will be equal to 3. So maximum value of the cardioid that will be equal to 2. Circle ആയിരിക്കും പുറത്ത് വരിക. Now when r equal to 1 plus sin theta, so sin 0 is 0, so that will be equal to 1. Then r equal to theta equal to pi by 2 എത്തുമ്പോൾ r value becomes 2, so it will take the maximum value. And again when theta is equal to pi, it will take the value 1, and theta equal to 3 pi by 2 വരുമ്പോൾ -1 ആവും, 1 minus 1 0 വരും, and again at 2 pi it will reach the value 1. So that is going to be the shape of r equal to 1 plus sin theta. ഇനി നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് area of the region inside the circle and outside the cardioid. So this is the cardioid and this is the circle, so the required area will be this portion. Now for finding the required area, so what we'll do is we'll subtract the area of these two curves. അപ്പോൾ എവിടം തൊട്ട് എവിടം വരെ സബ്ട്രാക്ട് ചെയ്യണമെന്നാണ് നമുക്ക് നോക്കുന്നത്. ഓക്കെ.